Welcome to your week 9 lecture video. This week we will talk about sustainable engineering design. It is important that as engineers we understand how to create sustainable products, processes, or services. And we need sustainable products, services, and processes more so than ever with the current climate that we'll live under. So let's start our conversation on sustainable engineering design. So today, learning goals are as follows: that you understand what sustainability is and what sustainability is not. There are quite a few misconceptions regarding what sustainability is and what sustainability is not. So I'm hoping that in this video, we can clarify that. Then the next learning goal for this lecture would be for you to understand the mechanisms involved in each design stage of the sustainable design process. So we'll look at the sustainable design process and putting it within the context of the cradle to grave cycle of a product or process. Then lastly, I'm hoping that we would be able to show real life examples so that you can apply the sustainable design process to real life problems, especially your Lab 3 project, which is as real as it gets. So let's start our conversation. There we've got a crystal ball with a peaceful earth and the way we think everything should be. And sustainability really is the responsibility for everyone, because you've got everybody's hand around the crystal ball, just to show that we all have a responsibility towards sustainability. However, the responsibility is even greater for us as engineers, because we design the products and processes and services for the most part that people use. And so we are the people that would really make a determination whether a product is sustainable or is not sustainable. So as engineers, the responsibility is even greater on you or on us. So I'd like you to think about what your definition of sustainability is and just note down your definition of sustainability by completing the blank. So sustainability is ... What from your prior knowledge do you think sustainability is? I do not need you to Google it right now, just from your own prior experience or knowledge without Googling it, just jot down somewhere what sustainability is or what sustainability is not, but the definition of sustainability. Also, another question I'd like to ask is, do you think that the term sustainable can be used interchangeably as the term or the word green? In other words, does sustainable equal to green? Does sustainable mean the same thing as green? Take note of your answer, yes or no, and why? Because we will be having this conversation for the first part of this lecture. We will seek to unwrap what sustainability is, and then now look at if sustainability is the same thing as green, so that we can meet our earlier determined learning goal number 1, to understand what sustainability is and what sustainability is not. So let's get started on that process of thinking, is sustainable the same thing as green? So what will really help us understand if sustainability means the same thing as green is to get into the definition of sustainability itself. And from there, we can also get into the definition of green and then understand if both of the same or not. So we'll be killing two birds with one stone, not literally killing two birds with one stone, but we'll be unraveling 2 points together, looking at the definition of sustainability, and then also based on the definition of sustainability and green determine whether the two words should be and can be used interchangeably. A Charlie Brown comic there, that was one of my favorite comics growing up. So what is sustainability? Sustainability is the ability to meet the needs of the present without compromising the ability of future generations to meet their own needs. In other words, as engineers, if we are developing or designing a sustainable process or product, we should design a product or process that will ensure that we meet our present needs, the needs of our clients, the needs of our generation, but at the same time, we need to bear at the back of our mind that our products and services should not in any way compromise the ability of future generations to equally meet their own needs. So I need you to start thinking about your Lab 3 project. Your Lab 3 project, the product or the service or process that will emerge from your Lab 3 project, is it sustainable? Will it impede in any way the ability of future generations to meet their own needs? So let's unwrap sustainability a little bit more. The experts say that sustainability has three different aspects. It has the social aspect, the economic aspect, and the environmental aspect. And so green, when we look at the definition of green, green actually has to do with the environmental and health impact of products and processes. So when we think about the term green, we're thinking about the impact on the environment, the impact on health that a product or process or service has. However, sustainability includes the social equitability of a product, the economic viability of a product, and the environmental bearability, or we could say the green aspect of a product with regards to whether or not that product or service or process has an adverse effect on the environment or on the health of living organisms. Hope that is clear. And so based on that definition, I wonder what you think the answer is to our earlier question of, is sustainability the same thing as green? You're right, the answer is no. Sustainability is not the same thing as green. It does not mean the same. I know some laypersons use the term interchangeably. However, as engineers, this is one of those terminologies that we are pedantic about, and we say that sustainability is not the same thing as green. You've seen what sustainability means and what green means. Green is just a subset of sustainability. And so you can imagine sustainability as a larger umbrella with social aspect, economic aspect, and environmental aspect tucked under it. And for a product to be sustainable, it needs to be socially equitable, economically viable, environmentally and health-wise bearable. So I hope you are now able to differentiate between the term sustainability and green. So I'm now going to show you sustainability models that are commonly used in industry. And please remember that we are building up to looking at the sustainable design process that you're going to apply to your Lab 3 project and apply to any future product or process that you would design as an engineer. So one of the first models we'll look at is the tripod model of sustainability, which reiterate what we just talked about in the previous slide. And so again, here at the center, we have, or at the intersect, we have sustainability or sustainable, meaning that if a product is termed as sustainable, it is socially equitable, and we'll explain what that means shortly. It is economically viable, and we will explain what that means shortly. And it also meets the green aspect, meaning that it has no adverse effect or impact on the environment or health of the users. So let's talk about social equitability, whether a product is socially equitable or not. When we consider the social aspect of sustainability, we think about if the people working in the manufacturing company or working in the life cycle of the product are being paid fair wages. So if individuals, workers are not being paid fair wages, when we looked at the complete cycle of a product, then that product is not socially equitable. If a product is to disrupt and overhaul without adequate compensation, the culture or heritage or livelihood of a group of people, a certain demographic group of people, then that product or process is not socially equitable. An example is the North Dakota pipeline that was going to be laid on a Native American historic or heritage site. That would really disrupt what Native Americans hold to be sacred without adequate compensation or replacement or substitute for them. And as such, we would say that that North Dakota pipeline would not be socially equitable. I know that in the press, we heard a lot about the environmental impacts of the North Dakota pipeline, but we did not really hear a lot about the social equitability of the North Dakota pipeline. But as engineers, if you want to consider sustainability, you need to look at the social equitability of a product or service. Fair trade is a good example of products that are sustainable or at least meet the social equitability of sustainability. So I would say for the most part, fair trade products ensure that workers, farmers especially, that provide the raw materials for products are being paid fair wages or are being adequately compensated. And they also ensure that those workers have proper personal protection equipment and are not exposed to hazardous substances that could have adverse effects on their health. And so I hope that kind of puts in context what we consider when we think about the social equitability of a product. So economic viability, again, as I mentioned a couple of weeks ago, I think at the start of Lab 3, as engineers, we seek to develop products or services that will end up in the hands of our clients or customers. We are not just creating these products to end up in our garages. We want them to be bought, and as such, we also want to make profit. So you need to consider the economic viability of your product or the profit margin of your product or process. Is it profitable? If it's not, then it is not termed as sustainable. For your Lab 3 projects, we are asking for a minimum of 25% profit margin, and later on, as we progress through Lab 3, I will post a video that talks about that a little bit more, how you can figure out the profit margin of your product. Next, the green aspect, which includes environmental impact and health and impact on the health of your customers. So is your product environmentally friendly? For example, is it biodegradable? Can it be recycled? Can it be repurposed? Does it have any adverse health impact on the users? For example, if your Lab 3 project is going to contain ingestible material, so you need to make sure that you're not using BPA plastic that is known to be a possible carcinogen, so that your users' health is not adversely impacted. So that's the tripod model on sustainability. A very common model used to represent what sustainability is. I know there are different flavors of the tripod model now on sustainability. Some, I think, have added a fourth sector. Another model that represents what sustainability is considering the environment, economy, and society, which just reiterates what we talked about in the previous slide. We also have the people, planet, profit model, again, just reinforcing what sustainability is, that if a product or process is to be termed as sustainable, it needs to consider people, it needs to consider the planet, and it needs to consider profit. And using the examples I gave when we talked about the tripod model. So this is an activity that I would like you to carry out in your Microsoft Teams channels to determine if this Nestle water bottle is green or sustainable. I will post this slides on Canvas, and so it will be available to you and in your Microsoft Teams channel. Please deliberate whether this Nestle water bottle is green or sustainable, and I will post the answer to this question by next week Tuesday. But between now and next week Tuesday, I need you to deliberate on whether or not this Nestle water bottle is green or sustainable, and if coal is green or sustainable. So now let's get on to our next slide, which really is the focus point of today's lecture. We started out by defining what sustainability is, understanding if sustainability means the same thing as green, because it's important that we understand the terminologies that we're using, and we agreed that sustainability is not the same thing as green. And we looked at the different models of sustainability. So now we will look into the sustainability design process, or what we call the cradle to grave cycle of a product. So this is really the cradle to grave cycle of a product, but you need to consider sustainability at each of the stages. So for example, we have the first stage in the cradle to grave cycle of a product to be raw material extraction. After the raw material is extracted, it is now passed on to a material processing stage. And there's a bit of packaging there. And then it is moved on to part manufacturing and package, then assembly and package too. Then after that, we get into the product use phase of that product, and finally the end of life. So let's use consumer electronics as an example, or as a case study for the cradle to grave cycle of a product. And in particular, we can use the cell phone or pretty much any basic consumer electronics. And we will focus on the metals being used in the consumer electronics just to create the chassis of the cell phone. So aluminum is predominantly used in consumer electronics. Aluminum is the metal that is commonly used in consumer electronics. Why? Because aluminum is sturdy, and also it is light. It's one of the lightest metals we have, and pretty cheap also. That is why we use aluminum in consumer electronics like your cell phone or your laptop, because you do not want to be carrying a laptop or a cell phone that feels like a brick. So let's look at how aluminum is processed and used in cell phones and ends up in cell phones. So raw material extraction for aluminum, we would be extracting bauxite. Bauxite is a natural ore, metal ore found in abundance in different parts of the world. And so the raw material extraction, that would be extracting bauxite. And so if we consider sustainability in the cradle to grave cycle of this consumer electronic product, your cell phone, we would apply the tripod model on the raw material phase. So we would think about the social equitability of extraction of bauxite. We would think about the economic viability of extraction of bauxite, and we would think about the green aspect, the environmental impact, the health impact, or the impact on the health of the workers extracting bauxite. And so if that process ticks all the three aspects of sustainability, then we can say the raw material extraction process of bauxite is sustainable. And then we move on to the material processing. So bauxite will now get processed into aluminum, and then aluminum would then be part manufactured, cut out into different sheets, and then sent off to the cell phone assembly company or manufacturer to assemble the aluminum parts with all the other electronic parts. And then you get your cell phone, which you use. And then at the end of life of the cell phone, the question comes up again, what do you do with your cell phone? Then you start thinking about the sustainability model. At the end of life, are cell phones put into landfills? Are they repurposed? Are they recycled? Are there biodegradable parts in the cell phone? At each of these stages of the cradle to grave cycle of a product, you must consider the sustainability models, the sustainability tripod model, or any of the sustainability models, and ask the question, is it socially equitable, economically viable, and net zero? Net zero meaning it has zero adverse impact on the environment and zero adverse impact on the health of consumers or users. Let's use the Tesla car as an example. I love the Tesla cars. Tesla cars claim to be net zero. And yes, they might be net zero at the product use stage, but really they cannot really claim to be net zero in the entire cradle to grave cycle of the Tesla car. Because when we consider the raw material extraction, part manufacturing, etc., of the Tesla car, we might actually find out that it is not net zero. And at the end of use of the Tesla car, what do you do with it? What do you do with the part? And so Tesla, in my opinion, cannot claim to be completely net zero. They need to be specific that they are net zero at the use stage. So I hope this kind of puts in context what sustainability is, what the sustainability design process entails. It just means applying sustainability at each of the stages of the cradle to grave cycle of a product. So let's carry on our conversation and look at supply chains. I just included these two arrows on distribution to show that transportation is also very important to consider in the cradle to grave cycle of a product, because transportation is one of the main culprits of the increase of carbon footprint in the environment. This is another cradle to grave cycle diagram that again starts with raw material extraction, but also includes transportation, then manufacturing, also highlights packaging, which is very key, and carries on with transportation to the use stage and then the disposal. Again, you need to be thinking about the cradle to grave cycle of your Lab 3 projects. What will happen to your Lab 3 projects after its end of use, after the use stage? At the end of life stage, what do we do with your Lab 3 projects? But now I just want to spend a few minutes to focus on transportation and supply chain of products and the adverse effects of really complex supply chains on the environment. So let's use Nutella as an example, the manufacture of Nutella, and look at the price tag we are actually paying on one bottle or one jar of Nutella, which most of us really like to eat. But is it worth it? And I'm not saying please to stop eating Nutella. I'm just saying that we need to consider the supply chain of products and the adverse impact it has on the environment. So Here we have the supply chain of Nutella, and I want you to take note of the green circles. The green ovals or circles are where raw materials are gotten from. So cocoa is gotten from Nigeria, palm oil is gotten from Malaysia, Brazil provides sugar, Turkey provides hazelnut, and then I think France gives a bit of vanilla and sugar. So those are the sites for raw material extraction. Then take note of where the factories are, the manufacturing plants for this, for Nutella. You find one in Canada, one in Russia, a couple in Western Europe, and then one in Australia, some in the southern Brazil, but none in Nigeria, none in Malaysia, none in northern Brazil. So this creates a really complex and long supply chain. And what happens with complex and long-winded supply chain is that we get higher carbon emissions, which mean higher contribution to the depletion of the ozone layer because of a product. What would happen if, for example, Nutella had a manufacturing plant in Nigeria or Malaysia or northern Brazil? That would shorten the supply chain and as such reduce the amount of carbon emissions contributed by a jar of Nutella. So we might buy our Nutella for $5, but really the cost to the environment is far greater than $5. It's in hundreds of thousands or if not millions to the environment. So the charge for yes, future engineers is to think creatively about the supply chain of products to ensure that you reduce the carbon footprint associated with the manufacture of a product so that the world is not paying more than we should, or future generations don't end up paying for our, should I call it, our own enjoyment of products, and we impede the ability to produce the same. Next is the olive jeans, another crazy supply chain. Here, the yarns are sourced from Republic of Korea. Fabric is woven and dyed in Taipei, China. Fabric is cut in Bangladesh. Zippers produced in the Philippines. Assembled jeans in Cambodia. What a complex supply chain. And so just imagine the actual price tag we pay for a pair of Levi jeans. It might cost $60 to $100 here, but the overall price tag for future generations is more than $100. And again, the challenge for US future engineers is to consider sustainability and consider reducing supply chains of products and thus reducing the carbon footprint contribution of a product. So that is due to transportation and crazy supply chains of products. Then just looking at even the health impact of some products is also important. Consumer electronics are known to consider large amounts of hazardous substances that are dangerous to human health. And when we talk about engineering ethics later on in the semester, we will spend more time on this, but I just want to put this out there so you will consider the impact of your Lab 3 projects, the impact of your Lab 3 products on human health, especially at the end of life stage. What happens to your Lab 3 product? Just like the cell phones shown in this diagram, most of them end up in the hands of the person in the diagram that sits down to unpick and unpack the cell phone for some metal parts. And just that process is really, really dangerous and hazardous. Lots of pollutants being produced. And we use stainless steel as an example because stainless steel is another metal commonly found in consumer electronics. Anywhere you have a nice shiny finish, we, for the most part, would use stainless steel. And so these are some of the facts about stainless steel. Stainless steel welding produces fumes that contain carcinogenic metals like chromium, nickel, vanadium, cadmium oxide. These are known facts. Workers may be at risk to develop lung cancer, kidney damage, and cardiovascular disease. Occupation as welders, occupation as a welder has been associated with 25 to 40% increase in lung cancer, known fact since 2012. So this is not even current recent information. This is pretty dated information. So this has been known for a long time, but nothing substantial has really been done. Dermal contact with certain grades of stainless steel can lead to skin and eye sensitization. Contact dermatitis is well documented to be due to nickel and chromium content of stainless steel. And yet we sell jewelry and purchase jewelry for our loved ones that have nickel. In most parts of the world, especially in Europe, nickel is pretty much banned in jewelry, especially jewelry that children would use. In the United States, I think it's advisory. And so I present this slide to you so that you are thinking and considering the health impact or the impact on the health of your potential users for your Lab3 project, if you're going to be considering the sustainability of your Lab3 project. And so just to wrap up, I would like you again in your Teams, in your Microsoft Teams channels, to just start deliberating on your Lab3 project. How sustainable is your Lab3 project? Thinking about the social equitability of your Lab3 project, thinking about the economic viability of your Lab3 project, and also the green aspect of your Lab3 project. I hope that your Lab3 projects are sustainable. Please take note that your Lab3 projects might not be completely sustainable. All that I ask is that you consider sustainability. I need to see you thinking about if your Lab3 project is sustainable and looking for ways to make your Lab3 project sustainable. Thank you for watching the video. I know this is one of the longer videos, but I hope that it's been informative. Please, once again, if you have any comments or questions or concerns, come for office hours or send me an email. I look forward to hearing from you or seeing you during office hours. Thank you. Bye. Stay safe.